Okay. Welcome to your graphing gateway. Check this out. Ask a lot of questions if you don't know what I'm doing, because you want to have this exactly right. So, domain of radical x. I'm going to do a little picture of each of these graphs. So you all back there, radical x looks like that. Domain starts at 0 and goes to infinity. Those are the input values. You can put in, it's basically the x for these types of graphs, 0 to infinity. So you're so excited. You guys are starting to show, you were so quiet before lunch, but now post lunch, you guys are all pumped up. You guys got the range of cosine -1 to 1. Anything unusual about that? And then it says, state the intercepts of the function y equals e to the x. It only has one intercept. You have to know how to do e to the x. The graph of it has one intercept, and it happens at 0, 1. Now, what would change that is any transformation of e to the x would change that intercept. So just be prepared for some kind of transformation of that, but that's the idea. Again, stop me for anything. State the end behavior of natural log of x. Natural log of x, if I draw a little picture of it, is the inverse of e to the x. Looks like this. And the end behavior is you want to do the two infinity things. So you go, as x goes to positive infinity, ln of x goes to infinity. That's y goes to infinity. So remember what you do is you trace out as x goes out toward the right, as x goes to infinity, what is your function doing in general? Like, where is it headed? And this graph just keeps going up, 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 up. Okay, and then you do the other direction as well. So you turn it around. So you want to make sure as x goes to negative, now in this case x doesn't go to negative infinity, but it does go towards 0. So the end is like where, there are only two ends. You do end behavior for however many ends you have, like where the arrow tips are. So we go x goes to 0, then y goes to negative infinity. And once upon a time that was really confusing for some of us, so is it okay with that? Does that sound okay? You trace, you say as x goes toward every possible end in the graph, tell me what y does, and that's the output of the function. Anything weird in there? Okay. Let me know. It says state the intervals of increase and decrease for the absolute value of x. Absolute value of x, it's a v, but I should be more specific. The slope of each leg of absolute value is, this has a slope of 1 on the right hand side. Goes up 1 over 1, and then on the left hand side it has a slope of -1. So whenever you're graphing it, it's not just random v's going off in opposite directions. It's just one has a slope of 1, the other has a slope of -1. Increase and decrease, it's increasing on the right and it's decreasing on the left, but we would say, more specifically, it's increasing on the interval 0 to infinity, and I'm going to put a parenthesis on that. I'm sorry, I put a bracket. From 0 to infinity, and that's decreasing on the interval from negative infinity to 0. Cool? And then find any asymptotes of the function 1 over x. And 1 over x is this lovely graph with an asymptote at x equals 0. And if we shifted that graph at all, the asymptote would probably, horizontal shift would move it around. So just as an aside, 1 over x minus 2 would have a vertical asymptote at x equals 2. That's just an aside, in case you wanted to know. Hey, you guys, what's happening?
There you go. Mr. Seeley, do you want a cookie?
Of course,
Okay,
if you're
just for
offering.
you.
Well, thank you.
Just for you.
That was awesome. How did you swing this?
Here you go. Take as many as you want.
I'm just going to take these crumbs, right? This crumb and this one, so it's not like two.
That's gross.
You're welcome, Mr. Seeley.
Thank
Yeah,
you,
you're welcome.
Maddie. Thank you, girls. That was really,
Next
really
year when I
nice.
take your pre-calc class, you have to give me a good grade, okay?
We'll keep bringing cookies. We'll talk.
Remember that, okay?
Keep bringing cookies. We got options. She will ace the course anyway. And wouldn't have it any other way, if you know her. So, sketch the inverse of cosine of x. There is none.
Is y equals 0 also an asymptote?
Oh yeah, thank you. That's the horizontal. So the big one is, so y equals 0. Yep. X equals 0 and y equals 0. Thank you. So The only thing that might happen is that vertical asymptote for x 1 over x minus 2 would be x equals 2. Horizontal asymptote, that can shift as well. And this is also an aside that I want to put in there, is 1 over x, if you put plus 3, then that horizontal asymptote will shift up with it. So there is something, just keep in mind that those horizontal and vertical asymptotes move with the shifting of the graph. And these are an aside. These are just extra information in case you were wondering what I might else ask of you. So just some ideas. Cosine of x does it have an inverse? And if you graph cosine of x, that means after you rotate it over the line y equals x, do you get a function? And if you turn this on its side, what happens, sorry that cosine graph didn't hit very well. If that cosine graph is drawn properly, even then, it still doesn't pass. As you rotate it over that over y equals x, you get a graph that spins, that's climbing upward. It flies up the axis like this, which does not pass the vertical line test, and so it's not a function. So we say there's no inverse on this one, because the inverse is not a function. Okay, next is symmetry for x cubed. This one has, and I'm always grabbing, this is all about knowing the graphs, so I keep graphing them, because I'm expecting you to also be able to do that. This has odd symmetry, symmetry about the origin. Asymptotes for e to the x, there is one at y equals 0. The way that graph works is it hovers up against y equals 0 and never touches it. So there's e to the x. Sine of x, odd, even, or neither. And if you graph sine of x, it actually is odd, interestingly enough. Every point you can reflect over the origin and get the same point. So it has odd symmetry. Cosine, by the way, is even symmetry. It has symmetry about the x-axis. I'm sorry, the y-axis. And I'm going to put that on here. Cosine is even. That's y-axis symmetry. Because I could ask you about that. There is a graph. This I'm going to be kind of detailed. So 1/2 x, absolute value of x minus 2. You guys know this is a right to shift. I'm sure you're good with that. And then this is a vertical shrink. So you want to know what happens. These are transformations. So half as big. So I'm going to take this v, I'm going to move it right 2. And usually for a v, I would go over 1, up 1, over 1, up 1, so on, like this. But because of that 1/2 that I'm employing there, making it half as big, I go over 1, up a half. Instead of over 2, up 2, I'm going over 2, up 1. Instead of over 3, up 3, I'm going over 3, up 1.5. What you get is all the heights are half as big. Just drew that one in the wrong spot. And so you get a graph that's less steep. So this is the correct graph, the green looking one. So I shifted it right 2 and then made it half as tall. A regular V graph would be over 1, up 1 in each direction. It has slopes of 1 and -1. So keep that in mind. The absolute value graph is now shifted right and squished. Vertical shrink. Okay, cosine. We did this one. So I once upon a time had you guys painfully learn this, but eventually I think you kind of adopted that you were okay with this. But what I'll do is I'll just transform this graph. First I'll start with 1 and -1. And I'll graph my regular cosine curve. So I'm going to put in here, so I might graph it like this. And transform it, and then I can just graph it up and over, and it would end at 2 pi. I'm making some more room for myself because I like big graphs. It's really hard not to sing a song. Okay, I'm gonna hold back. Okay, so that's what I'm gonna use, n0. And all I'm gonna do is transform those values. I'm gonna just shift to those values. So when I do, excuse me, the right pi over 4. So if I could spell right, that'd be really nice. This would be right pi over 4. What that means is I'm going to take all the x values, I'm literally going to add pi over 4 to them. So plus pi over 4 and plus pi over 4. So that's the process I'm using. And remember, I'm just going to use a couple of values on the x-axis. I'm going to use 0 pi and 2 pi. That's all I'm going to do is I'm going to add pi over 4 to those. That's it. That's all I need to do that on the horizontal axis. I'd like to simplify that and find out what those values are, which I'll do in a second. Like pi over plus pi over 4, I'd probably